Hello students and my dear friends. Today we are again in the chapter Arithmetic of Integers and in exercise 3.2. Before starting this exercise, let us recapitulate something. Here already you have got the general idea of this chapter in general mathematics, isn't it? Like Euclid's division lemma you got, so you have a better idea of division algorithm. Here let us consider a number 15. Suppose 15 is divided by 3. Okay, this is dividend, divisor. What is the quotient? 3 5 15. Okay, 0. Here you see remainder is 0. Okay, then again another case. Let us increase it by 1. 16. 3 5 15. Remainder is how much? 1. 17. Let us take now. 3 5 15. Remainder is 2. Let us again increase it. Now it is 18. 3 6 18. Remainder is 0. So when this divisor is 3, remainder may be 0, 1, 2, but it is not increasing. We know that this is the general idea, general knowledge, that the remainder cannot be more than the divisor. For that reason I am explaining this. Okay, you know this. So here this 15 is equal to here 3 into 5 plus 0. 16 equal to 3 into 5 plus 1. This is the division algorithm or division lemma. Okay, so if any integer is divided by another integer b, q be the quotient, r be the remainder. So a equal to this into this, bq plus r. Now what is the condition of r? R is, you see, r always starts from 0. And what is the maximum value of r? Here in this example we have got maximum value of r is 2. That is which is less than, just less than 3. So here r is less than this b, but less than how much? Here we can say it is equal to 0 also. But here r is less than b and r is greater than 0 or equal to 0. Here this means r is greater than equal to 0. If we reverse the order, is it okay? With this idea, let us start this question. Now dear students, let us read the first question. What is given? Show that the square of an odd integer is expressible in the form this, 3k or 3k plus 1. My dear students, here at first you have to know that the given integer is odd integer. Okay, we cannot do anything, we cannot change it. It is odd integer, so we have to consider an odd form. Okay, so here we have to understand that given integer is odd integer. So let a be an integer and suppose b be another integer. B equal to how much we have to consider? You know it in general maths already, you got it. You may know better than me about this. B equal to 3. Okay, then we have a equal to bq, 3q here plus r, where r is equal to, what are the possible values of r? Let us write all the possible values. First value is 0, 1. There are b is less than 3. From these 3 we can say that there are, always you should know this, if b is 3 there should be 3 values of r. If b is 4 there are 4 values of r. If b is 100 there will be 100 values of r. Possible values 0, 1, then next value is 2. Okay, my dear student, again I am saying that this given integer is odd integer. It is given, we cannot do anything. So please try to understand that. How do you know that this is odd? Because it is given in the question. Our intention or our motive is to prove that square is in this form. That's all. We are not about to find whether it is, how it is odd integer. We do not know. It is given. Okay, so let us take all the possible 3 cases. For first case, case 1, when r is equal to 0, then a equal, now what is the general confusion? Some student may think what sir is saying about confusion. You see, this is odd integer. Now where is the confusion? If q is 1, please try to understand. If q is 1, a is 3, odd integer. All right. If q is 2, what is the value of a? A is 6. 6 is not an odd integer. Okay, this is the confusion. So do not think about that this is odd or this is even. Given in the question odd integer, so we'll take it as an odd integer. We'll not consider this is even or odd. We'll not think about this. Think about that this is odd integer. Okay, then only there will be no confusion. Otherwise you will think that this question is totally wrong. Question is not wrong. Question could not be arranged properly according to me. This is my general idea. My personal opinion is that this question was not properly arranged. I may be wrong, I don't know, but personally I feel this. Okay, so square of odd integer. So at first this is odd integer. Square 3q square 9q square a square. We have to arrange in this form. All right, you know it, you got this in general mathematics. 3 into 3q square a square 3k, where k equal to 3q square. Okay, k is this. K doesn't have any perfect or particular value. K may be anything. K here it is 3q square. In some other case it may be different. Doesn't matter. Now case 2. When r is equal to 1, then what is a? A is 3q plus 1. 3q plus 1. Let us take it square. 3q plus 1 square. Now you know the if we expand it, a plus, this is of the form a plus b whole square. So it is a square plus twice ab plus b square a square. This is 9q square. This is 6q plus 1. Now you have to think this can be arranged in which form, either this or this. Obviously this, because plus 1 is there. 3 square, sorry, a square. Then from here we need that 3, so let us take 3 common. So it is 3q square plus twice q plus 1 a square equal to 3k plus 1. This is k. Okay, where k equal to 3q square plus twice q. Alright, now let us move to this third possible case. Okay, have you understood up to this much? Okay, let us move to this case 3. When r is equal to 2, then a is equal to 3q. You see, here we are substituting a equal to 3q plus, third case r is equal to 2, so a equal to 3q plus 2. We have to square it because it is in the question. Show that the square of an odd integer, these are all odd integer, it is given in the question. Square a plus b whole square, a square plus twice ab plus b square, 9q square, 2 2 ja 4, 3 ja 12q plus 4. Now you think this can be expressible in which form, this or this? Obviously this. How? You see, a square 9q square plus 12q, this 4 can be written as 3 plus 1. Alright, now from here we can take 3 common, isn't it? A square equal to 3q square plus 4q plus 1 plus this 1. Okay, so this is a square plus 3k plus 1. We will assume that this is k, where k equal to 3q square plus 4q plus 1. So we have arranged all the form, all the square form, either as 3k or 3k plus 1, 3k plus 1. Okay, so let us write the statement at the end. So always don't forget to write the statement. So the square, this is important point, square of an odd integer is expressible in the form 3k or 3k plus 1. Okay, this is the thing. Is it okay? My beloved students, now we are in question number 2. This question already you have got in general mathematics, isn't it? Then also we have to do, show that the cube of an integer can be expressed in the form 9k or 9k plus 1 or 9k plus 8. So directly let us do. Let a be an integer and b equal to how much? We never consider b equal to 9, isn't it? We consider 3 because it is given as, so that cube of n, if we take cube of 3, it is 27. In that 27, 9 is there because 27 is 9 into something, 9 is 3, 9 into 3. So here a be an integer, b equal to 3. Then we have a equal to, how we write? 3q plus r, where r is equal to, what are the possible values of r? You will start always from 0, 1, 2. Yes, this is 3, so there will be 3 possible values, and the largest value is always smaller than this. Okay, so let us take the 3 cases. Case 1, when r is equal to 0, then a equal to how much? 3q plus 0 means 3q. What do we have to do? We have to cube it. Cube. ঠিক আছে, cube কৰিলো 3 cube 27 cube আমাক কেনেকৈ অ্যাৰেঞ্জ কৰিব কৈছে? 9k কৰিব কৈছে। ঠিক আছে, a cube 27 can be expressed as 9 into something, 9 into 3q cube. ঠিক আছে, so a cube is 9k, where k equal to 3q cube. Yet k value 3, k doesn't have any particular or a fixed value. Okay, it is not given. So here k we have considered as 3q cube. In other case it may be different. Do not worry for that. Okay. Case 2, when r is equal to 1, then if r is 1, then what is the value of a? A is equal to 3q plus 1, r is equal to 1. What do you have to do? Again cube, a cube, 3q plus 1 cube, a plus b whole cube. What is the formula? A cube plus 3 a square b plus 3 a b square plus b cube. Okay, so it is a cube 27q cube plus 3 q square into 1 plus 3q into 1 plus 1, a cube 27 q cube, 3 9 is 27, q square 3 3 is 9q plus 1, a cube. We have to make in this either 9k plus 1 or 9k plus 8. Plus 1 is there, so obviously in that form 9k plus 1. So what we have to take common? 9. Okay, so from here 9 is common from here. So let us take 9 common. So it is 3q cube plus 3q square plus q plus 1. All right, let us do the remaining part here. So here up to this much we did here. So a cube is equal to 9 into k plus 1. Let us write. So a cube equal to 9k plus 1, where k equal to, here k equal to this part, 3q cube plus 3q square plus q. Let us write. Okay, next let us take case 3. Case 3. In case 3 we'll see, in case 1 we consider r equal to 0, in case 2 we consider r is equal to 1, in case 3 we shall consider r equal to 2. When r is equal to 2, then a equal to how much? Let us substitute here, 3q plus 2, 3q plus 2. What we have to do again? We have to cube, make it cube, a cube. So it is 3q plus 2 whole cube, a plus b whole cube, a cube plus 3 a square b plus 3 ab square plus b cube. This is the general formula. So this is a cube. 3 cube is how much? 27q cube plus 3 into, this is 9q square into 2, 3 into 3q into 2 square is 4, 2 cube is 8. Okay, we are very close now. This is 27q cube plus 3 2 is 6, 6 9 is 54, q square 3 3 is 9, 9 4 is 36q plus 8. So at the end we are finding that plus 8 is there. So this will be in this form. So by this we understand that 9 we have to take common from this part. So let us take 9 common. So what will be left? 9 3 is 27, 9 cube 6, q square 9 6 is 54 plus 9 4 q, alright, plus 8. So a cube is equal to 9k plus 8, where k equal to, let us write this part, 3q cube plus 6q square plus 4q. Now let us, we have express either the cube express, we have expressed as in the form 9q or 9k or 9k plus 1 or 9k plus 8. Now at the end we have to write the statement. So have you understood? Now dear students, we will start question number 3. Let us read the question. For any natural number, n belongs to n, means for any natural number, prove that this is an integer. Okay, now here again this is the application of division algorithm. Let us take here in place of a, n is given, so we will take n. Let n be an integer and b equal to, how much we will consider? By this we can understand b equal to 6, because this is either we have to divide by 6 or in a multiple of 6. Okay, we have by division algorithm what we have, n is equal to in place of a let us write n equal to bq plus r. What is b? 6q plus r. Okay, where r is equal to 0. We'll always start from 0, 0 1 2 3, how long? Up to 6 values, means up to 5, 0 1 2 3 4 5. So there are 6 cases. So case, let us see how much we can do. Case 1, if we get the similar result, okay, for few example we will write similarly. Okay, now case 1, when r is equal to, first case, r is equal to 0, then n is equal to 6q. Okay, n is equal to 6q. Now this value of n will substitute here. So this is equal to n into n plus 1 twice n plus 1 by 6 is equal to how much? N is equal to 6q. Okay, then 6q plus 1, n is equal to 6q. So 6q plus 1, this is equal to 2n, means 2 into 6q, 12q plus 1 divided by 6. We can cancel this 6. Now what do you think about this? Product of 3 numbers. These are some integer, these. Product of 3 integers is always an integer. So here this equal to q into 6q plus 1 into 12q plus 1, which is an integer. So we have proved this is an integer when n is equal to 6q, or for the first value, or for the first case. Now let us take the case 2. This is very simple question, lengthy but very simple. When r is equal to 1, then n is equal to, second case, r is equal to 1, then n will be 6q plus 1. Okay, again this value of n will substitute here. So what we are understanding, that in all the possible cases, in all the possible values of n, we shall put here, we shall substitute here, then we have to show that this is an integer. This is the general idea of this question, or the concept of this question. So therefore let us take n into n plus 1 into twice n plus 1 divided by 6 is equal to n is equal to 6 cube plus 1. So this is, I want to directly 6 cube plus 1. Again this is n plus 1, so it will be 6 cube plus 1 plus 1. So 6 cube plus 2, 6 cube plus 2. Then this is twice. Okay, we have to do one more step. Twice of this. Okay, 2n twice of this. 2, 6, 12 cube. 12 cube. Okay, 2 into 1, 2 plus this one divided by 6. This 6. Okay, so what it is? Let us see. 6 cube plus 1, 6 cube plus 2. This is 12 cube plus 3 divided by 6. Now you see this is 6 cube plus 1. From here can we take anything common? We can take 2 as common. So what will be left? 3 cube plus 1. From here what is common? 3 is common. So 4 cube plus 1. Okay, 6. So 2, 3 just 6 cancel. So it is 6 cube plus 1, 3 cube into 3 cube plus 1 into 4 cube plus 1. Here again this is a product of 3 integers. So which is an integer? Which is an integer. Okay, now let us take one more case here. Case 3. Case 1, case 2 done. Case 3. When r is equal to, you see, this case is done, this case is done. Now let us take r is equal to 2. Then n is equal to, dear students, here you see n is equal to, if r is equal to 2, n is equal to 6 cube plus 2. 6 cube plus 2. Okay, so then this value of n we have to substitute here. Let us check what happens. Therefore this value n into n plus 1 twice n plus 1 divided by 6, n 6 cube plus 2, n plus 1, n, this is n, n plus 1. So with it again we have to add plus 1. So 6 cube plus 3. The next one is twice n plus 1. So at first let us take twice of it. What is the twice of this? 2 6 is 12 cube, 2 2 is 4, then plus 1. Okay, divided by 6. Now here, dear student, here from here 2 is common. So what is left? 3 cube plus 1. From here 3 is common. Twice cube. What will be left? Twice cube plus 1. And it is 12 cube, 12 cube, 12 cube, then 4 plus 1, 5. 6, 2, 3 is 6 cancel. 3 cube plus 1, twice cube plus 1, 12 cube plus 5. Product of 3 integer is always an integer. Which is an integer? Which is an integer? Okay, so in the first case we have got this is an integer. In second case we have got this is an integer. In third case we have also got this is an integer. So in every case we will get this is an integer. So let us write similarly. Similarly, for r is equal to, up to how much we did? 2. Okay, so these 3 are left. So let us write 3, 4, 5. We can show that n into n plus 1 into twice n plus 1 divided by 6 is always an integer. Okay, so for, let us write the statement, conclusion, for integer. Got it? Now my beloved student, let us start question number 4. Let us read the question. For any natural number, show that this is expressible in the form 6q, where k is also a natural number. Okay, so let us start. Here in place of a, again we have to start with n, because n is given. This is in the form of n. Let n be an integer and b equal to how much? From, by this we have to understand this is 6k. So let us write 6. Then we have n is equal to bq plus r, 6q plus r, because b equal to 6, where what are the possible values of r? 0, 1, 2, 3, 4, last value is 5. It will be less than this, and the number of values of r will be 6. Let us take the first case. Case 1, when r is equal to 0, then n is equal to how much? 6q plus 0 will be 6q. Let us substitute the value of n here. So what will be its value? N into 7n square plus 5. N is 6q. Got it? 7n square, 6q square plus 5. Let us substitute its value. Let us put its value. 7, 6 square 36, q square plus 5, 6 q 252 q square plus 5. Now this is in the form of this 6. Let us consider this as k, where k equal to q into 252 q square plus 5. If you want, no need to find the value of this. From here also you can write 6, this is q. Okay, this is not necessary that you will do all these steps. 6 into this, that is also k. This is, then you will write this is equal to k. Okay, then these steps are useless, no need to do. Here I am explaining, so I am trying to do all the steps. In exam you may skip the steps. Case 1 done. Case 2, when r is equal to next value 1, then n is equal to, what will be the value of n then? 6q plus 1, 6q plus 1. So let us take that value, n into 7n square plus 5. N is how much here? 6q plus 1. This is 7n square. N is 6q plus 1, n square plus 5. So this is 6q plus 1, 7. So let us expand it in the form of, this is in the form a plus b whole square. So a square plus, which is equal to a square plus twice a plus b square. So 36q square plus, okay, 6 to the 12, 12q plus 1, this is plus 5. Okay, from here 6q is not common, so we will not think about this. So this is 36 into 7, here we did. Okay, so product is 252 q square, 7, 12, 84 plus 7 plus 5. Okay, so this is 6q plus 1. Sum is too easy, but calculation is lengthy. 252 q square. So sorry, this is, here will be q, I missed that q. 84q plus 7, 5, 12. This is equal to, now my dear students, you can see each is a multiple of 12 actually. So obviously we can take 6 common, because in 12 6 is there, 6 to the 12. So no need to take 12 common, we'll take 6 common. So at the beginning let us write that 6q plus 1. So here if we take 6 common from it, 6 4 ja 24, 1 2 6 2 ja q square plus 6 1 ja 2 4 24, 6 4 ja q plus 6 2 ja. Okay, so this is 6. This one let us write k, where we have to write in this form. You see why we are writing suddenly 6k? Because we have to write 6k. This is k equal to this 6q plus 1, 42q square. I am writing very small, may not be visible, please adjust. Okay, next case. Case 3. When r is equal to 2, then n is equal to, here we have done the first case, second case, now we are in the third case. Okay, if we get the same result in these 3, we'll write similarly. Okay, just like the last question, no problem at all. When r is equal to 2, then n will be 6q plus 2, 6q plus 2. Okay, so So what is the value of this? N into 7n square plus 5. N is 6q plus 2. This is 7n square. 7 into n square plus, this is plus 5 plus 5. Okay, I'm writing this equal here, but this is not the rule. If we have written equal, so equal should be maintained like this. As there is small space, so I have written. Please excuse me for that. 6q plus 2, 7. Let us expand this. This is in the form again a plus b whole square. So a square, 36q square. A square plus twice ab. 6 to the 12, 12 to the 24q plus 4 plus 5. Alright, we are very close now. 6q plus 2. 36 into 7. 36 into 7. 252. 252q square. It was not there, no? No, it was not there. So 724. 768q, 28 plus 5. Okay, after that, here, okay, we have to do one more step, then only we'll take common. 252q square plus 168q plus this is 33. Okay, but we have to take 6 common. This should be shown as a multiple of 6. Obviously we can show. From here what is common? 2 is common. Okay, so this is 3q. If we take 2 common, it will be 3q plus 1. And from here what is common? Obviously 3 is common. So 3 8 ja 24, 3 4 ja q square. Then from here 3 5 ja 15, 1 8 18, 3 6 ja 18, 11. Okay, so then 2 into 3 6. 3q plus 1. Okay, then this 84q square plus 56q plus 11. Now this one we have expressed in the form of 6 into something. So this is 6k, where k equal to this part, 3q plus 1 into 84q square plus 56q plus 11. Now for all these 3 cases we have got this value is as 6k. Okay, so what we'll do for the remaining? Similarly we should write similarly for r is equal to the remaining 3 values 3 4 5. 3 4 5 we can show that n into 7n square plus 5 is also equal to 6k. K belongs to n. Okay, so last statement. So where k is a natural number. Got it? Dear students, now we have taken question number 5. Let us read the question. If n is an odd integer, okay, we have to know it. N is an odd integer, then show that this expression is expressible in the form of 16k. Okay, where k is any integer. So let us take in the usual form. We know it how to write. Let n be an integer and b equal to, some of you may think b equal to 16 we will consider. No, here we have to think in a intelligent manner. Okay, now b equal to, what is the least value of b is possible here? In this case we will think of that. If we take b is equal to 2 to the power 4, 16. Okay, but here 2 square is 4, will not take. So then if we have to, we take 4 to the power 4, okay, 64. Then 4 square 16. Okay, let us take b equal to 4. Okay, then we have okay, then we have n is equal to bq plus r, 4q plus r, where r is equal to 0, the lowest value is 0. Then there will be 4 total, there will be 4 values, isn't it? 0 1 2 3. Now case 1, when r is equal to 0, then n is equal to 4q, which is even, Okay, so we will not consider this case because n is odd integer. Okay, so this case is rejected. Case 2, when r is equal to 1, or directly you can do here the odd integer we can get for this when r equal to 1 and r is equal to 3. Okay, let us do in that manner also. When r is equal to 1, then n is equal to how much? 4q plus 1. Okay, now if value of n is this, which is odd, let us substitute the value of n, this value there. Okay, let us see what do we find. So therefore, or so, n to the power 4 plus 4n square plus 11 is how much? Okay, so this is 4q plus 1 to the power 4, then its value square plus 11. Okay, now whole to the power 4. At present we do not know binomial theorem, so let us do by ordinary method. So this is 4q plus 1 whole square, then its square. Okay, 4. Okay, later we will do 4q plus 1 whole square plus 1. So this is a plus b whole square. Okay, at first a plus b whole square. So let us express it: a square plus twice ab plus b square. Okay, its square. Now 4, a square plus twice ab plus b square plus this, sorry, this was 11, it is 11. Okay, now let us try to simplify this. This is 16q square, 2 4 is 8q plus 1 its square. Then let us multiply. 16 4 is 64 q square plus this is 2 4 is 8, 8 4 is 32, 32q plus 4 1 is 4 plus 11. Okay, now we know the formula a plus b plus c whole square. Can you remember? A plus b plus c whole square. What is the formula? A square plus b square plus c square plus twice ab plus twice bc plus twice ca. In class 9 we got this, in general mathematics we got it. So a square plus b square plus c square plus twice ab plus twice bc plus twice ca. This is c and this is a 1 into 16q square twice ca plus this is 64 q square, this is 32q plus 4 plus 11 is 15. Okay, 16 square how much? 256 q to the power 4 plus 8 square 64 q square, this is 1. 16 to is 32 into 8, or sorry, in this way also you can do 2 8 is 16, 16 16 256, 256 q cube, 8 to is 16 q, 16 to is 32 q square plus this is 64 q square plus 32 q plus 15. Okay, now let us arrange. 256 q to the power 4 plus next is cube, 256 q cube 9 term containing q square, 64 64 and 32. Okay, you see this term is 64 q square, 32 q square, 64 q square, 64 64 128. Okay, 128 and along with this 32 10 6 160 q square plus then term containing q 16 and 32. You see 32 and this 16, this 16q and this 32q we are adding 48q. Okay, plus this 1 and this 15 is 16. Okay, now here we want to do this case we want to finish here. So what is common? this should be expressed in the form of 16q. So 16k, sorry, 16 we have to take common. So 16 we want to take common. So obviously we can take common here. 256 means 16 in 16 into 16. That 16 will be left. 16q to the power 4. 16q to the power 4. Again here 16 will be there. 16q cube. Then 160. 160 means 16 into 10. 16 is taken common. 10 will be left. 10q square plus 48. 48 is 16 into 3. 3q plus this 16 is 16 into 1, so 1 will be left. So this is 16k, where k equal to 16q to the power 4 plus 16q cube plus 10q square plus 3q plus 1. So this is expressed, then this is expressible in the form of 16k. Now let us move to this case. Here you see, we will not do this, because when r is equal to 2, the number is even. Then we will take directly this one when r is equal to 3. Okay, in the next page. Then case 3. Case 3. When r is equal to, at first I thought that I will reject it, but I will show you, because some of you may be confused. That's why r is equal to 2, then n is equal to 4q plus 2, which is even. But we have to take all the odd cases. Case 4, when r is equal to 3, then n is equal to 4q plus 3, which is odd. Okay, so if it is odd, then we have to put the value of n or substitute n here. So what is this? N to the power 4 plus 4n square plus 11. Okay, now let us take this is in another way. Okay, in the case 2 we solved, we have expressed this n to the power 4, we have at first square, then we found its square. We use this formula, but we will do in some other way. Okay, you will do which method you like, which method you prefer. You see here, from these two n square is taken common, correct? So n square plus 4 plus 11. Method will be same ultimately. Okay, same expression will get at the end. N square, what is n? 4q plus 3 its square. Then here 4q plus 3 its square, then plus 4 plus 11. Okay, so let us expand it. A square plus twice ab plus b square. Then same thing. Okay, same thing we'll do, copy paste. A square plus twice ab plus b square. Okay, sorry, 4 is left here, plus this 4 plus 11. So this is 16q square, 2 4 3 is 12, 24q plus 9, 16q square, 24q, 9 plus 4, 11. Okay, so this is 16q square, 24q plus 9, 16q square, 24q, 13, 11. Okay, with 16 we shall multiply throughout. 16q square into this, 16q square into 16q square, 256 q to the power 4, 16 into 24. Okay, here you can see that we have shown the multiplication there. Okay, we'll take the help of this. So 16 into 16, 256, 16 into 24, 384, 384 q square into q, so it is q cube, plus 16 into 13, 16 into 13, 208, 208, okay, q square, plus 24 into 16, 24 into 16 is 384, 384, it is q cube, plus 24 into 24, 576, you know it, q square. Okay, 24 into 13, 24 into 312, 312 q. Okay, then with 9, 16 9 ja 144, 144, 16 9 ja 144 q square plus 9 into 24 q, 9 into 216, 216 q plus 9 into 13, obviously it is 117, then also I have shown, so I have to rub it, 117 plus this 9 into 39 is 117 plus this 11. Okay, so let us simplify. 256 q to the power 4 plus this 2 term, 384 q cube plus 384, 448. Let us add them. Okay, it is q cube plus, okay, so this is added, this is added, then term containing q square, 1 is 208, 1 is 208, 208, next is 576, 576, next is 144, 144, (928) q square plus term containing q, 312, 312, and this 216, 216, these two terms, 312 and 216, 528 plus 528 q plus 117 and this is 128. Okay, now let me wrap this part. So we have to express in this form 16q. So is 16 is common? Let us see. 16 will take common. So 16 into 16 q to the power 4 plus from 768 we have taken, we want to take 16 common. So let us divide 48. Okay, so it is 48. 48 q cube plus 928. 928. We want to take 16 common. 28. So this is 48. 48 q square plus 528. We want to take 16 common. Okay, so this is 33. 33 what? 33 q plus from 128 we want to take 16 common. 128 obviously it is 8. Okay, so this is 16k, where k equal to this long expression, it is not there. Okay, with it, so it is 16q to the power 4 plus 48 q cube plus 48 q square 33q plus 8. Okay, so in this way we can write that. So conclusion, so 16k, where k belongs to z. Okay, before finishing, can you say which method was easier, this method or the earlier one of multiplication? I think last method is better, is not it? Dear students, now we are in question number 6. Let us read the question. Question to us, so that an integer and its cube give the same remainder when divided by 6. Kiba eta integer ase, suppose moi ami eta example lo. This question is very interesting question. 8 eta integer ase, etu ami 6 di divide korisu. What is the remainder? 6 1 is 6, remainder is 2. ঠিক আছে, তার পাছত কইছে কি ইয়ার কিউব ল বলে. What is the cube of 8? 8 cube is 512. If we divide 512 by 6, what is the remainder? 6 8 ja 48, 3 2, 6 5 ja 30. The remainder is 2. In both the cases remainder is same. We have to show this. Okay, here in the first case, what is 8? 8 is this 6 into 1 plus 2, and in this case what is 512? 512 is 6 into 85 plus this 2. This expression, this term, not expression, this term and this এই নাম্বার দুটা কি হয় রিমাইন্ডার হয় রিমাইন্ডার বুঝাইছে তো এইটক আমি 6 into something plus 2 that remainder আর 512 আমি 6 into something plus that remainder so এই রিমাইন্ডার যদি সেম হয় তেতিয়া আমি এই কনক্লুশন আহিব পাৰিম যে an integer and its cube give the same remainder when divided by 6 আমি জানাকা দেখালে নহব we have to do in the systematic way so let a be an integer and b is equal to how much by that we can understand it is 6 then we have a equal to b cube plus r 6 cube plus r where r is equal to 0 1 2 3 4 up to 5 is it okay ठीक है case 1 when r is equal to 0 then what is a 6 cube plus 0 what is the remainder is 0 mind it here so therefore or a cube 6 cube a cube 6 cube is how much 216 cube can be added 0 here so in the cube the remainder is 0 we have got so in a remainder is 0 in the cube also remainder is 0 okay case 2 let us see how many cases we can do otherwise if we get the same result then similarly we obtain the same thing when r is equal to 1 then a equal to 6 cube plus 1 here remainder is 1 this one all right tar pasot etia cube to long 6 cube plus 1 cube ঠিক আছে a plus b whole cube কেনকা হবো a cube plus 3 a square b plus 3 a b square plus b cube correct so what is a cube 6 cube is 216 cube okay 36 6 square is 36 into 3 108 q square plus 3 6 is 18 q plus 1 দেখা ইয়াকো আমি ইয়াত 6 কমন আছে তো we can write like this 6 যদি কমন থাকে তেতিয়া হলে ইয়াত কিমান হবে 36 q cube হবে plus 6 1 just 6 4 8 6 8 ja okay q square 3q okay plus 1 এরো দেখা কেনকা ফর্মত 6 into something plus 1 আমি এক সাপোজ কিবা এটা বেলেগ কিবা লইছো 6k লইছো সাপোজ plus 1 where k equal to it লইছো 36q cube plus 18q square plus 3q okay so here what is the remainder here the remainder is also 1 okay in a the remainder is 1 in the cube the remainder is also 1 now let us take r is equal to now 2 suppose याद करिसु okay तार पाछत आमी जदि एटु सेम होला आमी सिमिलारली बोली लिखि दिम okay case 3 okay तो याद when r is equal to 2 লইছো তিয়া first case hol second case hol third case kori asu tia first case second case third case okay third case is going on so then a equal to here pura 6q plus 2 6q plus 2 here what is the remainder is equal to 2 therefore a cube 6q plus 2 whole cube ঠিক আছে কিউব কৰিছো আকৌ a plus b whole cube আমি এক্সপ্যান্ড কৰিম ইয়াত কৰিছো জায়গা নহ'ব নহ'লে a cube plus 3 a square b plus 3 a b square plus b cube correct okay তেতিয়াহ'লে a cube এটো দেখা 6 cube হৈ গ'ল 216 cube আছে okay তাৰপিছত this is 6 square 36 আৰু এটা 6 ঠিক আছে 216 হ'ব আকৌ cube কে মাল্টিপ্লাই কৰি চোৱা 3 6 যে 18 18 4 যা দেখা 3 6 যে 18 18 2 square 4 18 4 যা 72 হ'ব নহয় 72 q plus 8 okay আমাৰ রিমাইন্ডার কিমান ওলাব কৈছে 2 ওলাব কৈছে ঠিক আছে ট্রাই কৰো a cube 216 q cube plus 216 q square plus 72 q plus 6 plus 2 এইটক আমি এনেকা লিখিছো কেলে আমাৰ রিমাইন্ডার 2 ওলাব লাগে সব ঠিকই ওলাব যদি ইয়াত সবতে 6 কমন হৈ যায় নহয় জানো ইমান লৈকে 6 কমন হ'ব লাগিব চাও I think we'll get 6 common ইয়াত হলে কিমান হ'ব 36 q cube 36 q square okay 6 1 যা 6 2 যা plus 1 ঠিকই আছে তো এটু a cube 6k plus 2 where k equal to suppose 36 q cube plus 36 q square plus 12q plus 1 ইমান লগে কৰিলো ঠিক আছে এতে রিমাইন্ডার ইয়াত কিমান ওলালে therefore remainder is equal to 2 in the cube also remainder is 2 similarly এতে similarly লিখি দিম similarly for r is equal to 3 4 5 we get the same result ঠিক আছে ইয়াত জায়গা নাই তথাপি মই কৈছো তোমালোক লাস্টত ইয়াত লিখি দিবা so an integer and cube give the same remainder when divided by 6 I hope you will be able to do thank my beloved students we are in the last question of exercise 3.2 question is this is question number 7 question is show that the difference of a number and its square is always an even integer so here let us start actually this is very easy question now let us consider with an usual method or usual procedure what do we write let a be an integer and b is equal to how much we'll consider the value of difference here even number is a multiple of 2 b is equal to 2 then we have a is equal to bq plus r twice q plus r where r is equal to 0 then 1 okay these are the two possible values case 1 when r is equal to 0 then what is a twice q okay now what we have to find show that the difference of a number and its square so now let us take the bigger at first square is bigger a square minus a that is 2q a is 2q okay 2q square minus a what is a here 2q let us simplify this is 4q square minus twice q we have to show that this is an even integer how can we show an integer is even if it is a multiple of 2 so let us take 2 common here so this is 2q square minus q suppose this is 2 into something k where k equal to 2q square minus q here you write which is even okay so first case is done now case 2 it is not from here also you can write 2 into this so this is 2 into something means which is even you can write here also not you can skip this line not necessary at all case 2 when r is equal to 1 then what is a let us substitute here 2q plus r is 1 okay now we need a square minus a twice q plus 1 this is a square minus a what is a twice q plus 1 okay so Let us expand it. A plus b whole square, a square, 4q square, a square plus twice ab plus b square minus twice q minus 1. Okay, minus sign is there, so sign got changed. So this is 4q square plus 4q plus 1 minus 2q minus 1. This 1 can cancel. This is 4q square. Let us simplify. 4q minus 2q is 2q. We have to take 2 common, as we have to show it is an even integer. 2q square plus this is q, okay, which is even. Okay, so the last conclusion let us write here. So difference, what we will write? Difference of a number and its square is always even. So the difference of a number and its square is always an even integer. Is it okay?